Thanks very much, Marty. Good morning, everyone. This is Sean Idonato. I'm the CEO of Kineta. I'm here with my colleague, Craig Phillips, who is joining me. I'm a scientist by training. I've worked in the biotech industry really my entire career. That is my second company, which I founded here in Seattle. Our previous company was a company which was venture capital financed, exited in an M&A transaction in 2008. And we're happy to be here today telling you a little bit about Kineta.
What are you doing?
I'll look forward to having Craig Phillips, our president, step in and introduce the company, and then I'll pick it up from there. Thanks, Craig.
Great, thanks very much, Sean. Yeah, we're here to talk to you about Kineta. We're developing novel, first-in-class life science technologies, really to treat cancer, and especially focused on hard-to-treat cancer.
No.
In fact, can I ask, someone has their speaker on and a dog barking. If you could mute yourself, that would be appreciated. Thank you. So I'm going to talk about what our research programs are. You know, as a company, we're based in Seattle. We're really focused on innate immunity, and that's really the center of our expertise and focus. The market sectors that we're looking at are immuno-oncology, which is the largest growing market in the pharmaceutical field. Our first drug program we're going to talk about today is an anti-Vista antibody. And this is a monoclonal antibody that reprograms the tumor microenvironment. And what that does is that allows the immune system to regulate and control itself, thereby suppressing and killing cancer cells. So this is it's a novel drug program. Sean's going to do a bit of a deep dive into this morning. And we're looking to file our IND at the end of this year. We also have a novel drug for chronic pain. This is a non-opioid alternative for chronic pain. That drug's currently in phase 1. And we've licensed that drug to Genentech Roche on a worldwide basis. So we're really working with them to advance this program through the end of phase 1. And at that time, Genentech takes over full control of the program. So novel research focus. On our next slide, it just shows kind of where each of these drugs are in development. In addition to the Vista program we're going to talk about this morning, we also have a discovery program in immuno-oncology, and we anticipate designating another program out of that research effort late this year, beginning of 2022. And we also have a legacy program that's focused on emerging viral diseases. It's a viral fusion inhibitor, and that's predominantly funded with non-dilutive financing from the NIH and other NGO organizations. And so with that, I'm going to turn it over to Sean to walk through the science. Thanks, Sean.
Sorry, thanks very much, Craig. It's a pleasure to be with everybody. As Craig pointed out in his opening description of the company, Kineta is really a biotechnology company that's focused on new drug development in the immuno-oncology and neuropathic pain markets. Immuno-oncology is our major focus, and one of the reasons for this, or the major reason for this, is it is the most active commercial market in the pharmaceutical industry. It's about an $88 billion market today. It's expected to grow to $158 billion by 2024. And certainly most of the institutional funding that's going into biotech companies is going into immuno-oncology companies. They constitute about half of the licensing and M&A transactions that occur in the industry every year. And they're also about half of the companies that have gone IPO over the last 3 years. And the sector has seen a very active IPO market. So immuno-oncology is a solid area for our company commercially. It also happens to be an area where I've worked in for most of my career. And then the neuropathic pain and neuroscience markets more generally are also a very active area, and they are actually second in terms of deal activity. And overall about a $6.3 billion market, mostly dominated by generic drugs. but expected to grow to 10 billion by 2027. So Kineta's principal focus is in cancer and in solid tumor in particular. And as you probably all know, cancer is a major public health problem in the United States. There are about 1.8 million newly diagnosed cases of cancer in the US every year, and that leads to about 600,000 cancer-related deaths. So that makes cancer the second most frequent killer in the US after heart disease or cardiovascular disease. And there are nearly 20 million people in the US living with cancer. And some of the types of cancers that make up the bulk of these tumors are really some of the most difficult to treat. So prostate, lung, colorectal, and breast are really the most common forms of cancer. While we've made some headway, I think, over the last decade in improving diagnosis and treatment of breast cancer, a lot of the other most common types of cancer that I just mentioned are really treated with very conventional therapies. And so new things are needed for these patients, especially patients who are diagnosed with advanced or metastatic cases who generally are more difficult to treat than when cancer is diagnosed early. So Kineta's approach to cancer is really focused on a branch of the immune system called the innate immune response. I think when many of us think about immunity, we think about the adaptive immune response. These are things like antibodies and T-cell responses that emerge over time, for example, following a virus infection or vaccination, and you need more time to develop that adaptive immune response. But the innate immune response can be thought of more as the first responders of the immune system that typically will become energized and come on within a few hours of infection. And the innate immune system is unusual in that it helps to modulate the adaptive immune response. So it can either be pro-inflammatory or it can be immunosuppressive. And having that really appropriately dialed in innate immune response initially is very important to having an adaptive immune response. And we think one of the major challenges in cancer therapy today, in particular cancer immunotherapy, is that we have an absent or immunosuppressive innate immune response, and that's really preventing the immune system from detecting those tumors as foreign and developing a robust immune response to tumor. Now, one of the major targets that we're really looking at is a target called Vista, and Vista is a drug target which is expressed in colder tumors. It is an innate immune target, and it is a target which is really representative or characteristic of those tumors that have an immunosuppressive tumor environment. They have a lot of those innate immune cells that are in there. They're immunosuppressive. They're blocking recognition of the tumor by the larger immune response. We tend to characterize these as colder tumors. Over the past 10 years or so, we've seen the emergence of first-generation immunotherapy in the anti-cancer space, and that has been through a couple of different treatment types called checkpoint inhibitors. And what's most interesting about checkpoint inhibitors is that they tend to work best in people who have an immune system that has some recognition of their cancer. And in those individuals, even in advanced cases of cancer, when they receive a checkpoint inhibitor, they can have very dramatic effects. So when we think about one of the most prominent cases in the popular press was Jimmy Carter, who had a very advanced brain cancer, but his brain cancer was recognized by his immune system. He was treated with a drug called Keytruda, which is a Merck drug, and he had a profound and long-lasting complete response to his cancer. Unfortunately, most of those tumors do not respond to the checkpoint inhibitors. They are those colder tumors, and we think Vista is a big driver in why those individuals don't respond well. So what does Vista do? Well, here we're looking at a lung cancer. So lung is one of those really prototypical types of tumors that we're talking about today. Most people who have lung cancer have a certain type of cancer called non-small cell lung cancer. Those tend to get diagnosed very late. About 60% of those individuals with lung cancer get diagnosed when they have a locally advanced or metastatic cancer that's not surgically resectable. So those individuals are sort of going down the continuum of chemotherapy and radiation therapy, and they have overall poor survival. And lung cancer is one of these cancers that the immune system does not readily recognize. And it's a cancer that expresses very high levels of Vista on immune cells in the tumor microenvironment. So those immune cells that are expressing Vista really prevent the immune system from recognizing that lung cancer is foreign. And that Vista expression is associated with poor immune surveillance of the tumor, poor overall survival, and really resistance to other types of immune therapies that are currently in the market. So what we've done is we've developed a drug that blocks Vista. It will help to turn those cold tumors hot. So it will help to blunt the effect of those immunosuppressive immune cells. That tumor will heat up over time. It will become populated with more immune reactive or inflammatory cells. And that will allow that adaptive immune response to emerge. And by blocking Vista, we expect those tumors to regress and be controlled by the immune system over time. So better, more effective control of the immune system by blocking Vista. And you can see that here in animal tumor models. These animal tumor models are, I have a couple of different types of models here. So we have some of these colder tumor models, like a melanoma model in the left-hand panel, and a hotter model like colon carcinoma in the right. And what we're really showing is tumor growth in mice that have implanted tumors. These tumors are super aggressive. So typically over 3 to 4 weeks, the mice develop tumors that are so large that they have to be euthanized. So this is a much more rapidly evolving model than we typically see in humans. And what we're measuring there are the rates of tumor growth in sham or placebo-treated animals in black, or in animals treated, for example, in the left-hand panel in red diamonds with an anti-Vista product. And you can see that that anti-Vista product actually has a significant effect on reducing tumor growth through that activation of the immune system. So it's not uncommon for us to get a 50% tumor growth inhibition with just an anti-Vista therapy. So strong single agent activity in preventing tumor growth. In the right-hand